In this video, we're going to learn about variation. But before that, don't forget to subscribe our channel. Click the notification. Okay. Click the notification bell here so that you will be updated whatever lessons. Okay. So that you will be updated whatever lessons I'm going to upload. And then please share and like our videos. Let's go back to our lesson. Our lesson is about variation. There are two different types of variation that we're going to discuss, which is the direct and the inverse variation. First, let's focus on direct variation. Direct variation have a general equation. The general equation for direct variation is y equals to kx. So as you're going to read this equation, y varies directly to x. Okay, y varies directly. Okay, y varies directly to x, or we can write that one as y. Okay, varies directly to x, where k is not equal to 0. Our k here is our constant variation. Okay? So let's try some examples. For example, we have if y varies directly as x and y equal to 24 and x equal to 3. First thing you will do is you have to find the constant variation. What is k? And then after that, after you find the value of k, next is you are going to solve now for the value of y when x is equal to positive 2. Okay, so first, find the constant variation with the equation y is equals to kx, or y varies directly to x. Then after that, substitute the value of this one will be our y sub 1. Okay, this one will be our x sub 1. This one will be our y sub 2 and x sub 2. Okay, so therefore, to get the value of k, you are going to use now y1 and x1. So therefore, the value of k now is equals to positive 8. Okay, then after that, we're going to find now the value of y when x is equals to 2. So we already solved the value of k, which is equal to positive 8. So therefore, you're going to substitute only the value of k and x so that you can solve for the value of y. So therefore, first we find the constant of variation, right? Which was k equals to 8, and then we are going to substitute now into y equals to kx. So therefore, our answer now will give us y equals to 16. Okay, so first thing you're gonna do, you have to find the constant variation, and then after that, you are going to substitute the value of k so that you can solve for y when x is equals to positive 2. Next. There is another method, okay, to solve direct variation, which is a proportion. Okay, so we have if y sub 1 equals to k x sub 1, then k equal to y1 over x1. And y2 equals to kx2, then k equal to y2, y sub 2 over x sub 2. So therefore, here we're going to use now proportion. y1 over x1 equal to y2 over x sub 2. Okay, so let's try some problem. So if y varies directly as x and y equals to 6 when x is equals to 5, then find y when x is equals to 15. So here we have y1, x1. We're looking for y sub 2, and then x sub 2 is equals to 15. So using our ratio and proportion here, in this case, we don't need to find the constant variation. We're going to find only the value of y. So therefore, we can write now as 6 over 5 equal to y over 15. And then doing the cross multiplication, we can have now as y equals to 18. 6 times 5, 90, and 5 times y, 5y. And then y equal to 90 divided by 5, which is equal to 18. Now let's try some applications for direct variation. According to Hooke's law, the force F required to stretch a spring x units beyond its natural length varies directly as x. A force of 30 pounds stretches a certain spring 5 inches. Find how far the spring is stretched by a 50 pound weight. So here, how can we substitute now the value of y and the value of x? So by analyzing the problem, the force here, the force F required to stretch a spring, and then here you can see varies directly to x. So therefore, our F now, or the force, will be our value of y, and the spring now the value of x. So therefore, we can have now force varies directly to x, which is the spring. So therefore, we can have now y, or F force 1 over x1 equals to force 2 over x2. Given that force 1 is 30, the length is 5 inches. When we apply 30 pounds, the length of the spring is 5. What if we will apply 50? We will apply now 50 pounds. How long it will stretch? So therefore, we will have cross multiply 30x and 250, x equal to 8 over, or 8, 1 over 3. So therefore, here guys, when you don't need to find the constant we have variation, we can go directly to proportion so that we can find now the unknown variable or the unknown given. Next, inverse variation. So y varies inversely as x. The same, k will not be equal to 0, such that xy is equals to k, or y equal to k over x. Y k over x compared to, we have the direct variation. We have the direct variation y equal to k x. So you can see now what is the difference between inverse and direct variation. Just as with direct variation, a proportion can be set up solve problems of indirect variations as well. So we can use as well, we have proportion to solve for inverse variation. A general form for proportion, so we have x1 over y2 equals to x2 over y1. Let's try some examples. Find y when x equals 15. If y varies inversely as x and x equals, we have 10 when y is 12. So which one is x1, y1? Here. So find y when x is 15. So therefore, we are looking now here for y when the given is x equals 15. So therefore, this one will be our x1, this one x1, and this one will be our y1 as well. So y or xy equals to k, or y equals to k over x. So therefore, to find the value of k, we are going to use now x sub 1 and y sub 1, right? So therefore, we can have now k equal to 10 times 12, or k equals to 120. And after that, solve for y. Y equals to k over x, right? Or xy equals to k. Then we will have the y equal to 120 divided by 15, which is equal to 8. Guys, don't be confused about here. Don't be confused about xy equals k, or we're going to use now y equals to k over x, because we just only multiply xy so that we can find k, right, on this process. Okay. Now, let's try for proportion. Okay, so given that, going back to the equation, going back to the general equation, we have y, okay, x1 over y sub 2 equal to x2 y1. So the given value of x, we have 15, x sub 1 is 10, and y sub 1 is 12. So we're looking now for y here. So using proportion, we can have now as x1 over y2 equals to x2 over y1. So therefore, we will have 15 over 12 equal to 10 over y. Okay, so here, don't be confused about giving the value of which one is y1, which one is y2. Okay, so as long as you are using, we have correct form of proportion. So therefore, here we can have now cross multiply, which is 15 times y, and 10 times we have 12. So we will get now y equals to 120 over 15, which is equal to 8. Okay, let's try in this example. Okay, let's try find x when y equals 27. If y varies inversely as x and x equals 9 when we have y equals to 45. So using our equation, y equal to k over x. This one will be our x1. This one will be our, or we can have x1 here, y1 here, x2, and y sub 2, or either of the two. Okay, so first we will find k. So using these two given values, so therefore we can have now 9 times 45 equal to k, which is k equals to 405. Now after that, we'll look for x. So x now, xy equal to k, which is x times 27 equal to 405. So x now equals to 405 over 27, which is equal to 15. Okay, so this one is showing how you will solve for k and the value of x. Let's check if our answer is correct. So we get 15, the same answer. Next, let's try some application. Okay, so the pressure P of a compressed gas is inversely proportional to its volume V according to Boyle's law. A pressure of 40 pounds per square inch is created by 600 cubic inches of gas. Find the pressure when the gas is compressed to 200 cubic inches. Okay, using proportion, we have given a pressure 40 pounds. Okay, that will create 600. So this one will be our x1, y1, and x1. Then this one will be our y2. So we can have now here, given for the proportion, x1, y2, x2, y2. So therefore, we can have now 40 and 200, x over 600. Therefore, we can have now x equal to 120 pounds. So here, just only determine which one is y, which one is x, and then you can solve for the value of a known given. Again, as what I've said, mathematics is not memorizing. You have to practice it constantly. Constant practice makes it a perfect way to solve problem. Okay? So thank you so much, and that's all for our lesson.